Oakley dokley, installment number 137 now, and we're looking at congruent triangles. Okay, so in this session what we're going to do is we're going to talk about what it means for two triangles to be congruent. Of course, we know what congruency means, but we'll talk specifically in the context of triangles for them to be congruent. And then from that, what we should be able to do is we should be able to talk about cases that ensure congruency. So what it means to be completely congruent, and then why we kind of get a little bit of a cheat to help us out with that, sort of. Okay, so let's get started. Now, congruency implies that two things are identical. Okay, so if two triangles are congruent, then we have two identical triangles. That only stands to reason. Okay, so triangles themselves have 6 properties. Every triangle has 3 angles. Okay, so if you have two congruent triangles, their angles must all be the same. That only makes sense. But that's not enough to guarantee congruency anyway. We also have 3 sides. So since every triangle has 3 sides, if the 3 sides are congruent, then we're good. Now, it's possible to prove that triangles are congruent without checking all 6 of those properties. Because sometimes if you can get 3 of those, okay, in a certain set, so certain groups of 3 properties, will guarantee that the other ones by default have to be the same. Okay, so it's kind of like a shortcut to understanding that all 6 are the same. So remember, the rule for congruency is they have to be identical in every way, but instead of showing all 6 things are the same, if we can show that 3 in certain types of 3s are the same, then we'll be able to guarantee that all 6 are the same. Okay, so kind of a shortcut, like. So cases that ensure congruency. All right, so the first one is called side, 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 or SSS. You'll see it written. And what that means, if you can say that all 3 sides of corresponding triangles here are congruent, so if 2 triangles have 3 sides that are the same on both of them, then that means that the 2 triangles have to be congruent. There's no way you can take 3 sticks that are the same length and put them together in 2 different ways. There's only one way to put them together because there's only 3 sticks. And that means if you have 3 sides that are the same, well, the triangles have to be congruent. There's no way that can happen otherwise. So the way we write that, we say if all 3 sides of 2 triangles are congruent, then the triangles are congruent. Okay? Or all 3 pairs of sides, if you want to say that. If all 3 pairs of sides are congruent, then that might be a better way to say it. All 3 pairs of sides are congruent. Then the 2 triangles are congruent. Okay? Second one is called the side angle side congruency. So sometimes we write that as SAS. Okay? So side angle side. What that means, and you got to be careful about this one and the next one. If I say side angle side, it has to be 2 pairs of sides that are congruent. So we've got 2 pairs of sides. These 2 are congruent, and these 2 are congruent. Okay, so 2 pairs of sides are congruent. And the included angle, so the angle that's in between the sides. If I had one of the other angles over here, that doesn't necessarily guarantee me congruence. It has to be 2 corresponding sides, or 2 corresponding pairs of sides have to be congruent, and the included angle. So a very, very important part of this particular group of 3 things that will allow us to have congruency is it has to be the included angle. Very important. And I keep repeating myself here, but I can't stress that enough. That's one that folks get wrong a lot, so be careful. Okay? Let's take a look at the next one. The next one says ASA. Okay, not acetylsalicylic acid, not aspirin, but angle side angle. So if we can say ASA, angle side angle, we have one angle and another, so we have 2 pairs, should be, of angles. So like alpha and alpha are the same, and gamma are the same. So 2 pairs of congruent angles and the included side. So it can't be just any random side. It has to be the side that's in between them. So the way that we say that is 2 pairs of angles and the included side are congruent. then we can use that to help us conclude that the triangles are going to be congruent. Okay? So while congruency really means that we have to have all three sides and all three angles to be congruent for two triangles, we don't necessarily, if we're trying to prove, for instance, that two triangles are congruent, we don't necessarily have to check all 6 properties. If we can prove that 3 of the things are the same following the patterns that we talked about, SSS and SAS and ASA, if we can use those patterns to prove that if we have 3 congruent pairs using those patterns, that can ensure that the triangles are congruent. So it's kind of like a shortcut. So the reason we're talking about all this stuff is what we do in our next topic is we're going to talk about proving congruency. And we're going to talk about proving congruent triangles and proving things about congruent triangles. But remember, if we need to prove that 2 triangles are congruent, we just need to show any one of these 3 patterns that's the same on both triangles. Okay? So there's no review or practice questions with this. It's just getting an idea about what those 3 things mean. We'll get into the practicing when we actually do the proofs of congruent triangles. Okay? Thanks very much.